Hello everyone, welcome back. In previous lecture, I started the topic plug gauges. Now let us recall about it. So in limit gauges, there were go type of gauges and no go type of gauges. The necessity and the principle of gauging, Taylor's principle. Then the types in which the plug, ring, snap gauges, major gauges. Then I explain about the plug gauge, progressive type, and this one is the plug no go and no go gauge on the both end of the gauge. This was the tapered or the conical section go and no go gauge. This was about the ring gauge, and remember one thing, in no go gauge there is small groove cut in the periphery to identify it. Now we will move on to the other remaining gauges. First one is the snap gauges. Snap gauges are used for checking external dimensions. As you can see in the figure, with the snap gauges we can check the external dimension. They are also called as gap gauges. They are specifically designed to measure the or check the gap between the component. A snap gauge usually consists of a plate or frame with parallel faced gap of required dimension. It is having the parallel faced gap for required dimension. Snap gauges can be used for both cylindrical as well as non-cylindrical work as compared to ring gauges, which are conventionally used only for the cylindrical work. As you can see in the figure, it is possible to accommodate cylindrical as well as non-cylindrical component in the snap gauges, while in the ring gauges you can see only cylindrical component can be checked. A double-ended snap gauge, as shown in figure, is having two ends in form of anvil. The go anvil is made to lower limit and no go anvil is made to the upper limit of shaft as usual. जो go part है वो lower limit के लिए बनाया जाता है और no go part है that is made for the upper limit of the shaft. This snap gauge is also known as solid snap gauges. These are also known as solid snap gauges. Similarly, over here it is also indicated with the red mark over here, so you can specify that it is a no-go gauge, and the blue mark or the no mark can be for the go type of gauge. Just remember one thing, that for go we will use lower limit, for no go we use upper limit of the shaft. The both go and no go anvils are formed at same end. Okay, you can see in the figure both go type of gauge and no go type of gauge both are formed at same end. Then it is called as progressive snap gauge. Similarly to the plug gauge progressive type, there is also progressive snap gauge. It is mainly used for checking the large dimension up to 100 mm. They are specifically designed to measure large dimension up to 100 mm. Go anvil should be at the front and no go anvil at the rear. As usual, you can see from the previous part of plug gauge, the go gauge was before the no go gauge. First comes the go and then second one is the not go gauge. So diameter of shaft is checked progressively by these two ends. This type of gauge is made of horseshoe shaped frame with I section is to reduce the weight of the snap gauge. It looks like a horseshoe, but it is having the section I to reduce the weight. We can say it is a circular I type. If you take the section, it will be I, but it is designed as a horseshoe shape. Now this snap gauge is also called as caliper. gauge. Sometimes it is called as caliper gauge. So this first one was called as solid snap gauge, and the second one is called as the caliper gauge. Now the snap gauge, an adjustable snap gauge as shown in the figure, consists of one fixed anvil. The part over here, this is the fixed anvil, and two small adjustable anvil over here. Within screw, you can adjust the position of this anvil. The distance between two anvil is adjusted by adjusting the adjustable anvils by means of set screw. These are called as the set screws. For go and no go gauge, separate screw are provided, and we can set to particular position these anvils. These adjustment can be made with help of slip gauges for specified limit of size. What we require to adjust the gauges, slip gauges will be required to adjust the anvil for particular size if you want to make a go and no go gauge. Okay, so you require a slip gauge, you will put that and you will adjust the anvil. They are used for checking the large size shafts. They are specifically used for the large size shafts. Now we will move on to the next topic, that is about the comparator. Today we will discuss the need of the comparators. While uh, explaining the dial indicator and other components, I explained that in mass production, identical component parts are produced on very large scale. To achieve interchangeability, these parts should be produced to those dimensional tolerances. As a result, inspection is often more concerned with the dimensional variation from standard or basic dimension of the part. To this extent, inspection becomes a process of comparing manufactured part to the master part envisaged by designer. The use of vernier micrometer will not be feasible because of the skill required, the time required to measure the dimension. Use of comparator require little or no skill for operator and eliminate human element for taking measurement and give quick, highly consistent result. Apart from the gauges, the plug gauge, ring gauge, and snap gauges, we there are used comparators which are used for quickly measuring the dimension of the part and eliminate the use of vernier and micrometer. As you know, the vernier and micrometer use in all skill and it also require time. While for comparator, it doesn't require any skill. It is just a simple type of indicator. We can just by comparing with the master gauge, we can get the error or the difference in dimension directly while checking the our actual component. So where the comparators are required, it is required majorly where the production is very large and that we want that the tolerance should be achieved and the part should be interchangeable. It needs to be checked perfectly. Now, the basic principle and operations of comparators. The comparator is first adjusted to zero on its dial or recording device with gauge block in position. First thing what we need to do, we need to adjust the zero on its dial or recording device with the gauge block in position. The gauge block is of dimension which the workpiece should have. Gauge block, which means that it can be combination of slip gauges which are of specified workpiece size that we dimension is required, so that gauge block will be used to set the zero on the dial indicator. The workpiece to be checked is then placed in the position, and comparator gives the difference in dimension in relation to the gauge block. What happens then next? वर्कपीस जो हमको चेक करना है उसको उसी पोजीशन पे रखा जाएगा गेज ब्लॉक को रिमूव करने के बाद, और जो भी डिफरेंस आता है गेज ब्लॉक और एक्चुअल वर्कपीस के बीच में, वो हमको डिफरेंस इन डायमेंशन शो करेगा. द डायमेंशन ऑफ वर्कपीस मे बी लेस देन, इक्वल टू और ग्रेटर देन द स्टैंडर्ड डायमेंशन. It can be less, equal, or greater. As you know, if the dimension is less or greater than the standard, the difference will be shown on the dial or recording device of the comparator. Thus, a comparator does not give the dimension of workpiece but gives only the difference between the standard and actual workpiece. But you can measure what is the dimension if you know the actual dimension of the workpiece, as it gives the difference between the both. So whether it is less or greater, it will show the difference, and it does not give the dimension but the difference between the standard and actual gauge. If the comparator, this difference is shown as a magnified on dial or recording device. And why we need a comparator? To magnify that difference. The difference between both is very minute, so sometimes we need a comparator to magnify it on the dial, and we can specifically check what is the difference between the two components. For example, if a comparator has a magnification of 1000, and if the difference between the standard and actual dimension of workpiece is 0.02 mm, it will result in pointer movement of 20 mm on dial or recording device of the comparator. The magnification is 1000 and the difference is 0.02, so 0.02 multiply 1000, so it will be 20 mm movement of the dial on the recording device or in the comparator. So we can easily identify the difference of micron with the help of comparator. Now, what are the essential characteristics of a good comparator? So first and the foremost thing is the robust design and construction. The design and construction of the comparator should be robust so that it can withstand effects of ordinary use without affecting its measuring accuracy. As you can see, the comparators will be used frequently and the tip of the comparator will be constantly come into wear, and it will be coming to the contact with the workpiece as well as the gauge blocks. So repeated removing and placing of that gauge block and workpieces will cause the wear of the tip, and frequent handling of the comparator will be required. So it should be having the robust design and construction, as all the mechanical devices should have the robust design and construction so that they can be durable. Second thing is the linear characteristics of scale. Now, what is linear characteristics of scale? That is the recording of the measuring scale, and it should be linear and uniform, which means the straight line characteristics, and its indication should be clear. Whatever indicated on the scale should be clearly visible, and it shows the linear characteristics. Then high magnification, as you can see the magnification, if the magnification is higher, then the difference can be known very easily and much greater differences can be detected with the small deviation of the component comparator tip. Fourth one is the quick end result. The it should give the result reading in the least possible time, so we can quickly check the all the component. Fifth one is the versatility. Versatility means it should be able to measure the wide range of measurements. Okay, it can be used to internal dimensions, external, or whatever the geometry of the component. It should be able to measure the wide range of measurement from a specific range in mm 0 to 100 mm, furthermore 100 more than 100 mm. So specifically, it should be versatile and for wide range of measurement. Minimum wear of the contact point, as I told, the measuring plunger should have the hardened steel contact or a diamond to minimize the wear effect. And last one is the contact pressure. It should be low and uniform. So the contact pressure should be low and uniform. If the tip deflection is larger and the contact pressure is not perfect, then we will have the wrong reading and we cannot gauge accurately measure the dimension. So this is it for today's lecture. Thank you very much for listening carefully. Have a nice day.